Welcome to Wisdom Education Services. You must have watched the first and second video of average. Now we are going to discuss the second point in the average. As we have already discussed the deviation method, which states that the sum of deviation of average from all the numbers is always 0. If you haven't watched the first and second video of average, I would recommend you to go through our first and second video and then go ahead and watch this video. So in this video we are going to do the average second point. Now as you already know that average is the number which lies exactly in the middle point in terms of magnitude. But what happens when these numbers are in arithmetic progression? So the numbers which are in arithmetic progression will always give equal deviation from the middle number. Now let's suppose we have this example. In this example the numbers are 20, 30, 40, 50 and 60. Now these numbers are in arithmetic progression. For those of you who do not know what an arithmetic progression is, arithmetic progression numbers are the numbers which have a common difference between them. Let's say this number here, number 20, and this number here, number 30, there is a difference of 10 between them. And this number 30 and 40 again has a difference of 10 between them. So the numbers which are in arithmetic progression has a common difference. So in this question, our second point states that the average of the numbers which are in arithmetic progression will always be the middle number. So if you can see from this series, 40 is the middle number. Now let's see how 40 came out to be the average. If you see the number 40, the number adjoining to it are giving it a deviation of -10 and +10. And if you further go down to the next numbers, they're giving a deviation of +20 and -20. So since the adjoining numbers are cancelling each other's deviation out, so always the middle number will be the average whenever the numbers are in arithmetic progression. Other way around, I can also say that when the numbers are in arithmetic progression, the middle number and the middle position lie exactly at the same point, which states that the middle number will always be the average. So in this question, 40 is the average. Now let us move ahead and try a different example and see if we can solve the question using the same method. Now let's see, we have these numbers here. Now what would be the middle number of this series? Now first of all we need to check whether the numbers are in arithmetic progression or not. So 20, 30, 40 and 50. There is a common difference of 10 between them. Hence these numbers are in arithmetic progression. So now how to calculate the middle number? If you can see clearly, these numbers, there are even number of numbers. Hence the middle number which will not be one of these numbers. So the middle number would be 35. So now here you were able to see that the average is 35 or the middle number is 35. But what if the series is so big that it becomes very nearly impossible for you to calculate the middle number? Then the second point illustrates that the average of the numbers which are in arithmetic progression is the average of the first and the last number. Now in this question, the first number is 20 and the last number is 50. Hence the average of this series is 20 plus 50 by 2, that is 35. So I'm elaborating a second point in detail. The average of numbers which are in arithmetic progression is the average of first and the last number. Now let us solve few questions on it, because this seems to be a pretty good point which can solve our questions very easily. Now let's use this example. In this example we have to find the average of 72, 75, 78 and 81. So since we can see that these numbers are in arithmetic progression because there is a common difference of 3 among the numbers. 72 plus 3, 75, 75 plus 3, 78, 78 plus 3, 81 and so on. So there are two ways to solve it. Either just find the middle number or add the first and the last number and divide it by 2. Since it would be really easy for us to find the middle number, and as we can clearly see that 78 is the middle number here, so the average of all these numbers is 78. So we do not need to use any deviation method or any calculations. We can just see the middle number and find the average. Now let us see another example. Now this example, it would be really hard for us to find the middle number, as we would have to write all the numbers on a piece of paper and then calculate the middle number. So what would be feasible for us is, we would just calculate the sum of first and the last number and divided it by 2. So as we can clearly see that these numbers are in arithmetic progression, so the first number is 45, the last number is 90, hence the average of all these series is first number plus last number by 2, that is 67.5. So I hope it's pretty easy. So let's move ahead to the next question. Now we are going to do some typical questions. Now in this question, we have to find the average of all 2-digit numbers which are divisible by 7. Now let us see, there are 2 clues given in this question here. The first clue is, let me just get a piece of pen, alright, and good color, that would be fine. Okay. So what is the average of all 2-digit numbers? Now we need 2-digit numbers and they should be divisible by 7. So what is the first 2-digit number which is divisible by 7? That is 14. And what is the last number which is divisible by 7? It's because we just need to find the first and the last numbers, as all the numbers which are divisible by 7 are automatically will be in arithmetic progression, because there would be a common difference of 7 between them. Okay, let me calculate the second number. The first number would be 14 and the second number would be 21. Okay, now let us calculate the last number. Now there is an easy way to do that. The last 2-digit number would be 99. So what we have to do is, we just have to divide 99 by 7 and see what remainder we are getting. So if we divide 99 by 7, we can see that we are getting a remainder of, so you can clearly see here, we're getting a remainder of a positive 1, which means the last number to be divisible by 7 and being a 2-digit number, it's 99 minus 1, that is 98. So the last number which is divisible by 7 and is a 2-digit number is the number 98. So hence the first number is 14 and the last number is 98. So the average is 14 plus 98 by 2, which is equal to 56. Let me take a quick recap here. So what I've done is, I have to find the average of all 2-digit numbers which are divisible by 7. So the first number is 14 and the last number is 98. So 14 plus 98 by 2, the answer is 56. Now let us move ahead to the next question. Now we'll get a little bit more complex question. We have to find the average of all 2-digit numbers which give remainder 4 when divided by 9. So in this question, once again, there are some clues here. First of all, we need 2-digit numbers which when divided by 9 gives me a remainder of 4. So what is the first number when I divided it by 9 gives me a remainder 4? That would be 4, but it's not a 2-digit number, so I have to add plus 9 to it. So the first number when I divided by 9 gives me a remainder of 4 is 9 plus 4, 13. So similarly, the next number would be 13 plus 9, that would be 22. The next number would be 22 plus 9, and the series would keep going on. But we have a limit to the series. The limit is we have to know all the 2-digit numbers only. So the last 2-digit number which is divisible by 9 is 99. But if I add 4 to it, the number would become a 3-digit number. So the last number divisible by 9, that is a 2-digit number, is 99. And if I add 4 to it, the number will become a 3-digit number, and that will cross our limit. So we would not be requiring this number. So we have to go one step back. Now to go one step back, we subtract 9 from 99. So the second last number divisible by 9 and a 2-digit number is in 90. So if I add 4 to it, the number would be 94. Hence, the last number in this series is 94. The first number in the series is 13. So we've got ourselves a arithmetic progression series. So the average of this series is 13 plus 94 by 2. Hence the answer is 53.5. So let me take a quick recap here what we did. We had to calculate the average of all 2-digit numbers, which gives the remainder 4 when divided by 9. So the first number which gives remainder 4 when divided by 9 is actually 4. But it's a 1-digit number, so we need to find 2-digit numbers. So if I add 9 to it, I'll get 13 as the first number, which being a 2-digit number gives remainder 4 when divided by 9. And the last number would be 90 plus 4, that is 94, which gives 4 remainder when divided by 9. Hence, the average of these numbers would be the first number and the last number divided by 2, that is 53.5. I hope it's clear to everyone. Now let us move ahead to our next problem. Our next problem says that there are 15 consecutive numbers. Now let me tell you what are consecutive numbers. Consecutive numbers are the numbers which come together in the natural number system. Let's say 4, 5, 6, 7, 8. These all are consecutive numbers. So there are 15 consecutive numbers, and the average of smallest 9 is 47. What is the average of all the numbers? So if you go by the normal method, you would be involved in a lot of calculations and a lot of hard work to be done. But we can solve this question mentally as well, but I'm going to show you over the slides as well. So there are 15 consecutive numbers, and just remember that all the consecutive numbers are always in arithmetic progression, right? So I've written these 15 consecutive numbers right here. These are the positions of the consecutive numbers. So the average of these 15 consecutive numbers would be 15 plus 1 by 2, that is the 8th number. So this is the number which I have to find out. And I've been given the average of the smallest 9 numbers. So according to our point, since all these numbers are in arithmetic progression, the average of the first 9 numbers would be the last number plus the first number by 2, which would be the 5th number. Hence, the 5th number would be the average of the smallest 9 numbers, which is given to us as 47. So all we have to do is we just have to find the 8th number. Hence, the 8th number would be 47 plus 1 here, plus 2 here, and 3 here. So 47 plus 3, 50 is our answer. So let me take a quick recap again here as well. See, we laid down all the 15 numbers, and the average of the first 15 numbers was 15 plus 1 by 2. That was the 8th number. And we were given the average of the smallest 9 numbers, which was 9 plus 1 by 2. That is the 5th number. So the 5th number was given to us as 47, and the 8th number would be just 47 plus 3, since all the numbers are consecutive and there is a common difference of 1 between them. Let's move to the next problem. I hope this is all clear to everyone. So in this problem, actually it's a previous CAT question, if I remember. Yes, it is. So there are 7 consecutive numbers in ascending order, and the average of the first 5 integers is n. What is the average of all 7 integers? So what I have to do is I just have to lay down the 7 integers. So since they are consecutive, that means there is a common difference of 1 between them, and they are in arithmetic progression. So the average of first 5 numbers is given to me. The average of first 5 numbers would be the first number and the 5th number by 2, which would be the 3rd number. So the 3rd number is given to me as n. So all I have to do is I have to find the average of the all 7 numbers, which is nothing but first number and the 7th number by 2, which is equal to the 4th number. Hence, the average of the first 7 numbers is n plus 1. So, we were asked to find out the average of 7 consecutive integers. The average of the first 5 integers was given to us, which was n, and the average of first 7 integers would be just n plus 1. So this makes our problems pretty easy to solve. Alright, so let's move to the next problem. So in this problem, we have to find the average of first 50 positive even numbers. Now guys, it would be very hard for us to find the exact middle number, right? So we just have to find the first number and the last number. So what would be the first number which is positive and even? Okay, 0 is neither even. 0 is an even number, but it's not a positive number. So our first number would be 2. So the first number which is even and positive is 2. So the last number which is even and positive and is the 50th number would be 100. So we've got the first number here, we've got the last number here. So all we have to do is first number plus last number by 2, which is nothing but 102 by 2. Hence our answer is 51. So we had to find the average of first 50 positive even numbers. The average would be the first number and the last number by 2. The first number is 2. Guys, 0 is not the first positive even number. Why? Because 0 is neither positive nor negative. So the first positive even number would be 2, and the last positive even number would be 50 times 200. Hence the average would be 2 plus 100 by 2, which would be 102 by 2. Hence the answer would be 51. Now let's move to the next problem. I hope things would be getting pretty easy for you to understand now. Now what we have to do in this question here is we have to find the average of the first 121 natural numbers. Now it's pretty easy. So what would be the first natural number? The first natural number, now let me tell you the definition of natural numbers. Natural numbers are the numbers which start from 1 and go till infinity. So the first natural number is 1, and the 121st natural number would be easy. It would be 121. So all we have to do is first number plus last number by 2. Since all the natural numbers are in arithmetic progression, hence my answer would be 122 by 2, which would be nothing but 61. Hence my answer is 61. So it was pretty easy for us to solve now. So we've all we used is, since all the natural numbers are in arithmetic progression, so what we had to do is we just had to find the first number and the last number, and we just had to add the first and the last number and divide it by 2. So this was the end of the second point. So we had pretty much good practice on the second point as well, with just an elaboration and extension of the deviation method. So do visit the website www.education.wisdomimmigration.com for more practice on the second point on average, and see you in next video.